Hello everyone and welcome back to Intro to College Chem. Today we're going to be doing scientific notation. So the thing to know about this notation is that all it does is represent its original value, right, in a smaller or more concise way. So all it really does is represent how many places to the right we should have, or how many decimal places to the left we should have, and this depends on if your exponent is either positive or negative. So let's start with the positive and see how it actually works. We're going to do this example once we understand how it works. So let's say we have the number 1.0 times 10. The answer we know is going to be 10. And this kind of gives us a way to be able to see that when we multiply by 10, all that really does is move the decimal place over by 1. And that rule stays the same. No matter how many 10s you have. So let's say here we have 1.0 times 10 to the second. We have two 10s. So we're going to move the decimal place 2 to the right, and that gives us 100. Another way to think about it is that you can solve for this 10. So it's like 10 times 10 is 100. 100 times 1 is 100. But once you get to like numbers like 5, it's kind of hard to multiply that like 10 to the 5 in your head or even in a calculator, and you're just better off using this format right away with your EE function in the calculator. But anyway, so we have 1.0 times 10 to the 5. So all that means is that we're going to go to the right by 5 decimal places. So 1, 2, 3, 4, 5. Now, of course, when you're doing it and you just see this value, you're not going to see the zeros there. So the way you can go about doing it is that, well, you have what you originally have, right? And then you can just kind of count the places you're supposed to go to the right. So here we have 5 10s. So 1, 2, 3, 4, 5. Our new decimal place is going to be right there. And after you do that, then you can just fill in the zeros that are supposed to go there. And that's how you get your new number. So that's how scientific notation works with a positive exponent. And as you can see with our top example here, 2 times 10 to the second, well, we're going to do what we just did. We have 2.0 like that. And we have to move over to the right by 2 decimal places because we have 2 10s, or the exponent of 2. Now our new number is going to be 200 as a result, like that. And that's how that works for the positive exponents. And it works that way because we're multiplying by 10. So whenever you see a positive exponent times 10 by a positive exponent, you'll always be moving the value to the right because the value will always be bigger. So remember, positive exponent means bigger value. So now let's do some negative examples here. As you can see now, it's the other way. 2 times 10 to the negative 2. Well, when it's a negative exponent, instead of moving the decimal place to the right, you're going to move it to the left. And in this case, we start here where the decimal place originally got us, and then we move to the left twice, so 1 and 2. So our new answer is going to be 0.02. Now, before I continue, I want to explain why it is that we move to the left instead of to the right, and it comes down to your exponent rules. So let's say we have, again, 2 times 10 to the negative 2. Let's just think about this 10 real quick. So whenever you have a negative exponent, that is going to equal, so 10 to the negative 2, that's going to equal the reciprocal of the same value. So that's going to equal 1 over 10 to the second. So now if we do the same multiplication 10 times, instead now we replace it 10 to the second, we're just dividing by 2 10s. And because we're dividing by 2 10s, we move to the left by 1 decimal place. If either you divide or multiply by a 10, it's always going to be 1 decimal place. So that's something you can always remember. And if you're dividing, it's going to go to the left, and if you're multiplying, it's going to go to the right. And you can apply that with your negative exponents. If it's a negative exponent, your answer is going to be smaller. If it's a positive exponent, your answer is going to be bigger. That's always going to stay true. So now, let's do these examples. We have 1 times 10 to the negative 4. So let's just set it up like we already did. We know our decimal place is right there after the 1. So now we have to go to the left 4 times. Let me give myself more space. We have to go to the left 4 times, right? So 1, 2, 3, and 4. Our new decimal place is right here, and then we can just fill in the zeros. 0, 0, and 0. So, because our decimal place is here, I'll add another 0 right before it, just so it looks nicer. So we have 3 zeros after decimal place. 1, 2, and 3, and then we can add our 1, and that's our new value. It's the same value, it's just the longer way of showing it. All right, so now let's do the same thing with a 5. We can actually, once you get a good idea of it, you can just go ahead and skip the process, and you know that there's only going to be one more 0 right here. But let's do it just to show how it works yet again. So we have 1.0, and we have to go to the left 5 times this time. So oops. So 1, 2, 3, 4, and 5. Our new decimal place is right here. And 1, 2, 3, and 4. So as you see, now we have 4 decimal places, or 4 zeros after the decimal place. So as you can see, all it does is move by 1 decimal place, depending on how many 10s you have. So yeah, let's keep going. Okay, so let's continue and do some examples that you might actually see in the course. So here we have negative 5.404 times 10 to the negative second. Now, one thing I would like for you to note is that whenever you have a value that is negative and you have a negative exponent, it's not going to affect the sign of the value at all. Remember, scientific notation, all it does is tell you how big or how small the number is, and it won't change the sign. So don't think negative and negative will make a positive in any way. That doesn't apply here. So let's go ahead and actually do this example. And let's start with what they give us always. And so it'll be negative 5.404. Since it's a negative exponent, we know that's going to be a smaller number than what we see here. And that's always true. So we have to move over 2 places to the left because it's a negative exponent. So 1, 2. So now we're just going to have a 0 here before the 5. Again, let me add a complementary 0 before the decimal just so it looks nicer. So we have 0.05404, and remember that's going to be negative because the notation does not affect the sign. So let's continue with that same logic onto the next one. Let's start with what they gave us, which is negative 9.114. And in this case, we're multiplying by 10 and just one 10. And since it's positive, we're going to move to the right this time. And since it's just 110, only one place to the right. So that would be our new value right there. So the new value would be negative 91.14. Alrighty, so that's doing scientific notation to a decimal. Now let's say you have to do a decimal into scientific notation. In this case, all you have to do is count how many places you're going and find out whether you're making the number bigger or smaller. Okay, so in this case, we want to get to at least just one number before the decimal place. So that would be 1 and 2 right here. So now our new value is going to be 2.5, right? But now we have to indicate how many places were moved, or how many places need to be moved to get back to what we started with. So now let's say we have 2.5, we have to move how many places and in what direction. So to get 2.5 back to 0.25, we have to move this by 2 to the left. And since we have to move to the left because it's a smaller number, we know our exponent is going to be smaller. So we can do 2.5 times 10 to the negative 2. And it's negative 2 because we have to change this value back to what we started with. And that just goes back to how we were doing in the previous steps. So now let's do an example with a positive exponent. Let's say we have 75,000. Well, let's say again we want to do a value that only has one place before the decimal. So let's say we want to do 7.5, right? Well, we have 2 sig figs here, and we have to get this 7.5 back to this 75,000. Well, we have to add zeros, and if we have to add zeros, that means we have to go to the right. So that means our exponent is going to have to be positive. So let's see how many places we would have to go. We start at 7.5. We go 1, 2, 3, and 4. So in this case, our final answer is going to be 7.5 times 10 to the 4. And all these values equal each other. So there you go. Alrighty, so I want to add one last thing that a lot of times people don't learn when they're learning scientific notation is you might sometimes, or rarely, but eventually see something in scientific notation, but the 10 is to the 0. And what happens with this is that the value just stays the same. If we remember exponents, whenever anything is multiplied by, it could be any number, let's say 5 to the 0. Whenever anything is multiplied by 0, no matter how big or small, the answer will always be 1. So 0.025 to the 0 is just 1. So in this case, 10 to the 0 is just 1. And if we do 3.5 times 1, well, that's just 3.5. So whenever you see something like this, 3.5 times 10 to the 0, or any number times 10 to the 0, it's just going to be whatever is originally there, because we're just multiplying by 1. So yeah, to recap, all you really have to know is you have to realize that negative exponents are going to represent a smaller number, and bigger exponents or positive exponents are going to represent a bigger number. When you multiply by 10, you move to the right by 1 decimal place. If you divide by 10, you move to the left by 1 decimal place. So go ahead and keep that in mind, do some practice problems, and you're going to be more than okay. Good luck.